Today we're going to continue on with roundabouts. This is lecture number 27, looking at some of the design elements, looking at a few videos. The videos may not display very well since I'm watching a video while doing a video, which that makes sense. So the link should be active in the PDF that's posted on Blackboard. So if you want to watch these in better resolution, then just go ahead and click that link in the notes, and then you can watch it straight from YouTube on your own device, computers or phones or whichever. Through that. Last time where we left off, we looked at some of the bigger picture design elements for roundabouts. We looked at fastest path, what some of the standard elements were, what the circulatory island is and the roadway, the splitter islands, the entering roadway, and all that. Today we're going to get into a little more of the nuts and bolts about it. So this is a design class, so we're looking at how to lay these out. And again, this is still coming from the NCHRP report, which is a free download, the informational guide for roundabout design. And this is how a splitter island is laid out. And I think it's interesting. It's very similar to what we looked at previously when we were doing islands, just standard islands at traffic signals locations. And you can see here, this is the line here. These two are the lines coming in. And I can switch over to pen mode here, see if my handwriting's any better. These are the pavement markings, right? So this is the pavement marking here and a pavement marking here. Whoa, not very good drawing. Through there, here's the pavement marking. As it goes around, you can see over here we've got this larger offset, right? And that's what we talked about before, is that at the leading edge of the island, so our traffic is moving in this direction, right? So at the leading edge of the island, we have a larger offset. And so in this case, they're suggesting that you use 3 feet. Again, this is just a guide. You don't have to. That transitions down usually to around 1 foot, and then it maintains that through here. And as it comes all the way there, so here it says down to 1 foot until it comes up to the end here. And then you can see also so here is our circulatory roadway. We've got vehicles going this direction out here, all right, through here. So again, this leading edge of the island, the closest part of the island as the car comes around, this is that pavement marking line, all right? So we've got a larger offset here, and then it narrows down about 1.5 feet. This is that circulatory roadway through there. Same thing on this, right? If you're exiting the roundabout, you're going to be coming this direction through here. We have the larger offset there. It narrows down to that 1 foot offset or so here. And then we've got, typical radii. Depends on, I wouldn't hold strong and fast to this 2 foot suggestion here for it. It just depends on how big your island still is when you end the island. All right, so if this is still 8 feet wide, you're going to use something bigger than a 2 foot radius. You'll probably use a 4 foot radius, right? Because that'll match it just perfectly through there. So it just depends on what the shape is, how big your offset is here, whether it's a multi-lane or not, roundabout through that, right? And then this gap between the islands, this is the curb line, right? So here's our curb line. This gap through here is for pedestrians. So with striping, we would usually have a crosswalk striped coming out of either side, right? And then our pedestrians can cross back and forth through the center here. And then this area in here, we talked about that a little bit last time. We try to keep that around 10 feet wide. And that gives us plenty of refuge room for the pedestrians to wait through there. And a lot of times we don't put the curb ramp in and then up on top of that, and then another curb ramp back down because this is too short through here. So we break the island in pieces, and then we keep this level across here. Well, there'll probably be a slight grade to keep the drainage flowing in the right direction. But that's how we would normally design one of these splitter islands through that. And what we start with, though, is we start with the edge of pavement out here, or we may look at this line here, and then we build everything off of those lines. And we talked about fastest path. We're going to see that again at the end of today's lecture through there. But we're working on this edge of pavement design is one of the crucial pieces coming in that we're looking at, and then we kind of build everything off of that as we work through here. So just keep that in mind. You don't start with the splitter island. The splitter island is what takes up the space once you're done. So you'll sometimes you start with the center line out here, where there are the vehicle path, and then you'll build off either side of it. And you can see this gets a little wider as we get up here. So we've got some flare. I don't know why I did that. We have some flare here as it comes in. We get wider, and then it tapers back. As you go this direction back to the south, I guess, through there. And then from that, whether you're doing the edge of pavement design first or whether you're doing this path first, then you're going to offset and find this inside line for the vehicles, your travel lane through there. And same on this exit, you're going to eventually work out until you find this line. Once you know where those two lines are and the circulatory roadway line, then you start building your island inside of that. And so that's the workflow when you're doing these island designs. Typically you start from the outside, then you work your way in. Your splitter island, the island pieces, this is the curved piece right through there. That's just taking up what's left. It's not a very glamorous way to say it, but that's what it is, right? We're just using up what's left, and we're making it into island through that, right? On this actual lane coming in, this is how we would normally design this coming in. You can see they've got to turn my pen back on. You can see down here we've got these circle points, or where the radii start and end, or where the curves start and end. And so for the edge of pavement we come in, this is where that curve would start. Here is where this curve ends, and it's probably a point of compound curvature, and it's going to move into this next curve through that. We're going to see some examples of that coming up here in a second. Again, so this is tangent back here, right? I'm not doing a good job drawing straight lines, am I? Here's tangent. That was much better through there. And then these are not the same. They're not only not the same radii, they have a different center of radius, and so that brings out. Oops, let's do that for. That brings out this width here, right? We widen out versus what the lane coming in was. This is probably more or less 12 feet back here. When we widen this out, this is 15 to 18, sometimes even more. Through that, we try not to make it so big that two cars can get side by side, because that confuses people, right? So 18 to 20 feet, people probably aren't going to try to pass. And through that, you get any bigger than that, and they probably will. So for a single lane roundabout, that's what this one is. That's what we would normally be looking at through there. The initial, when I took the class on how to design roundabouts, the initial thing they taught us was, keep that arc moving until it creates a tangent point on the inside, I guess it's the curb line for the central island here through there. And so this is an arc piece through that. Later on, they said, well, actually arc it more back here. Put a little, I gotta stop doing that. Put a little more curvature back here. I'm not doing a very good job showing that curve. Whoa, all right. We need to erase that and try this again. All right. So, and this time, actually arc it more, arc it more back here, and then have this become a tangent straight out until it intersects that island. Because this assumes that people will, cars come up here and stop, they're going to continue an arced shaped path, following that arc out into the road. When people stop, later on they said it may be better to actually draw that straight out, because people are probably going to try to go more straight ahead. So you curve them more back here. You're going to curve them in this region and not continue to curve through that. So this line would become a tangent, a straight line, coming from this point, connecting to some point out here on the center island. All right, and it'd be tangent to both. So that's the new theory in how to design these, so that when you're in your car and you're sitting right here, you are aimed in the right direction. That's a lot of scribbles, so that you can just come straight on through there, and you don't have to arc anymore, and then curve back to the left through that. Yeah, that actually, there's quite a bit of deflection here. There's more deflection here, less out in here in the vehicle path. how that affects your fastest path, it remains to be seen. It's a little bit different for every single roundabout. It's hard to say one way or the other that's definitely better or definitely worse. All right, through that. Same thing on the exit. So your vehicle path, you're coming through here, and then you're exiting out that way, right through there. I really need to, I'm definitely not the Khan Academy. I can't draw on the screen very well yet. And so again, instead of, you've got a curvature going that direction, and then you're another curve coming back that way, exaggerated, through there, that you could actually just look at it more as a tangent piece in here, and you come straight out and then tie into that point, and then the arc around. And then these open circles would be the end of the arcs on that. So that's your exit side. And again, once you get that designed, you'll know where this line is. I need to hold the pen a different way, maybe. And that and that line. From there, try this again. Oh boy. Then you do your offsets, whatever you need, and then you draw on your splitter island after that. All right. So that's one way to do that through there. This is a much larger radius one, and it just depends on this one. You can see the center of that island is probably about right in here, and here is your offsets. Remember, we had 3 different styles. Here's that center. We had 3 different styles, and so this one, that the entrance road, this is your entrance side, is offset to the left from the center of the island, right? So there's your offset. This is really good for deflection on incoming cars. It's really bad for deflection on the exiting cars or outgoing cars like that. Right, that's a really straight line. They're going to hit the gas. By the time they get to this crosswalk, they may be going faster than you want them to go. All right. So that's the main consideration there, is that we've got a lot of a good deflection here. People are going to be slowing down coming through this side. Coming from this side, not so much. Right. Truck paths are the next piece to check. So we did the fastest path. Fastest path, I think I can safely say, is never a truck. So the truck is not going to ever set your fastest path. The truck is always going to be probably the slowest path through there. Trucks just have a harder time navigating these, although not terrible. They do pretty well through that. And if it's any driver, truck driver or passenger car driver, either one, if they're familiar with the location, they're going to go here pretty quick. So we talked about the fastest path. That's passenger cars, and it's probably 16-year-old kids with a sports car are doing your fastest path through there. Trucks is a whole different issue. Is, remember, that swept path, and so that's the between the front and the front tires and then the last tires on the trailer. That usually defines our swept path, but it's these dotted lines in here through there, right? That's your swept path. So this whole area is being covered by wheels on the truck as it goes around, right? And you can see that it matches real closely. Maybe down here is easier to see now because I drew all over the other one. Look how close that is to the edges, right? So that part of the reason for that flare is it does let trucks get through there easily, and it's keeping off the curbed island. And this outside is quite often curbed as well. So we're keeping the truck off those curbs on either side, which is a good thing. That's what we want to do through there. You can see his front tires. They have to really, whoops, it doesn't like when I push down too hard. You can see it really has to oversteer to get back and get around. So he comes out here, then he cranks it hard to the right, and then he starts to go around the curve. Now look at this. This is his rear tires right here. And you can see it's up on this crosshatched area. And we call this crosshatched area the truck apron. And that is designed exactly for that reason. So that tire is going to continue around. You can see it doesn't get off of that truck apron until about right here. Through that. So that truck apron is specifically designed just for the rear wheels on the semi, on the trailer. Now, if he's going out this side, he doesn't use a lot of that path, just a little bit of it. If you're turning left, you come around 3/4 of the circle, those tires may be out there quite a bit. And so we try to control fastest path with the passenger car by building these islands in certain locations so that they have to arc their path enough to be slower. But then we have to go back and we have to sometimes widen out those areas more than we wanted to make sure a truck can fit. And so this is hurting your fastest path, is to get that truck through there. But we designed these for trucks, and so obviously it matters, and we try to do a good job to accommodate both through there. So here's an example, nice approach view. This is one on the north, I guess northeast side of Valparaiso, coming in one of their newer roundabouts up here at Vale Park in Silhavy. And you can see that here's our shark's teeth. This is our yield point for cars. Here's the extended, with this dotted line, the extended circulatory roadways, edge of pavement circle coming out through there. Right, and then this in the middle here is our truck apron. And you can see, as a car, I'm not going to want to go up on that curb. And even though it's a sloped curb and it's only 4 inches tall. And then we often put patterns in here. So this is often brick patterns, and it makes a rumble sound or vibration in the car. So people don't like driving up on there. They don't have to. Truck drivers don't notice it because it's on the trailer tires. Up there, they don't feel the rumble very much at all. But as a passenger car driver, you're not going to want to be up here. And that's the whole point. We want to keep you off of that. And so as a passenger car driver, all right, you're going to be, as you're entering here, you're going to come around this, and you're going to do this big deflection and come around that way, right? And that's what we want. We want you to have a lot of arc, a lot of deflection as you come through the roundabout, because that keeps your speed down in that 20 to 25 mile per hour range, right? Now, as a truck, the cab of the truck follows that same path, but the rear tires are probably going to drive up over that truck apron. Through there, and it's designed for it. It can handle it. It may have shapes. It may be a molded concrete, or it may be actually brick pavers, but it's beefy enough it can handle truck traffic, and that's what it's built for. This curb can handle it as well. All right, so this is a case where we actually want trucks to drive over our curb, which is unusual, but it does happen. All right, here's another example, different location. This is on a state highway. The last one was at a city street. Through there, but you can see we still have this nice truck apron in here. Here's that raised curb, but it's a mountable curb, so it's easy for trucks to get across through there. And so again, this one was actually designed in that newer style. You can see that's kind of a straight line, right? If I could draw straighter, connecting out here to the circle. Through that. So once you stop here and then go, you're lined up to enter the center of this lane, right? So that would be your path coming from this yield point back here. And this roundabout's not that old, but you can see here was the shark's teeth, and they've already worn off. So those pavement markings don't last very long, right? Typically you got to restripe every 2 years at a minimum, and if it's paint, probably every year. Through that. And this is a pretty high traffic one, a lot of truck traffic, so these markings get rubbed off a lot quicker through that. And the standard paint truck can't do these special markings. They can do these stripes. So it looks like they've come back and redone the striping. They weren't able to do these special markings. They didn't have the same equipment for that. So this is a good case. This was a contentious issue in the county I used to work at. It was on a state route, so the county didn't have a lot of say in it, but some of the commissioners were upset. And there's a lot of RV manufacturers, heavy manufacturing area through there, a lot of manufactured homes. So those are really long, right? So a standard truck trailer is 53 feet. Those manufactured homes, I think, are in the 80, 90 foot long stretch, and they're really wide. They're 12 feet wide, right? So they redesigned this roundabout from the original to make all these road lanes in here, the circulatory lane, the entry lane, the exit lanes, all wider to accommodate those extra large vehicles, right? Through here. Here's a view from a different side. Through that, you can see the truck apron really well in here. And this was a state design. They didn't have a lot of money for landscaping. They don't want to maintain a whole lot through there. So you can see they use a lot of gravel and some shrubs here in the middle. And you can kind of see where this sight line would pass, right? The sight line from here, from this point here, I can see across the entrance road, right? We talked about that last time, being able to see in the right spot. Right through here. So if I'm obviously parked, if I was coming around this circle here, right, I would have a sight line from that truck all the way back, and I can see quite a bit of ways. I can see the person as they enter and so forth. So that's one example of where you can see these sight lines here, and apparently no sight line like here coming back towards us, right? I can see all the way across. Whatever their design speed here must have been a little bit probably higher than 35. I've seen somebody enter this thing at like 40 and never slow down, but that's probably someone with a lot of either guts or wasn't paying attention. So I don't think they even braked as they entered. They just kind of rolled right straight on through pretty fast. But you can see where they've cut off the landscaping here in the middle through that. And so this, you can see over it, so it's okay to be a little bit higher as you come through, as long as you can see across. And again, this is an intersection sight distance piece, and so that's 3.5 foot tall object and a 3.5 foot tall eye through there. Here's this mountable curb out here. We've got inlets in the center, so this one's actually they've sloped this 2 directions, which is a little odd, but it's such a wide roadway. That's maybe one of the reasons. They have, this is your high point here, and you have water sloping in, so they have inlets on the inside. They also have inlets on the outside in spots, and sometimes just curb turnouts, letting the water into the ditch through there. So that's an example of design. And again, this is a really big truck apron right through here. That is really large, much larger than normal. Again, they're really concerned, but look at this. This truck has quite a long trailer on the back of it. He's not anywhere near being on that curb. And then looking from this other direction, I was using Street View, and I thought, oh, there's a truck right behind the Google car. So if I keep moving down this exit a little bit further, I'll see that truck even closer to the truck apron. So I did, and this is where I ended up. And you can see if you look real closely, right, the truck apron's here. That truck has got 3 or 4 feet before he's even close to this curb. Right now, he's doing the right job. He's doing how you're supposed to as a truck driver. He's got the front end of the truck, a couple feet off of this outside curb, and that's what you want through there. So he knows how to drive roundabouts and is doing a good job. And that's, his trailer tires are nowhere near that. So again, this was put in. They use some of the largest turning movement templates I've ever seen for this, to use those manufactured homes and get them through there. All right, so this is what a truck apron from a cross-section view would look like. And this was one from a project I worked on where, again, we had drainage on the inside as well. So we also had inlets set in here in the middle. So we are draining in 2 directions, much like that last one we just looked at. As this one is draining that way, and this water is draining there, and it breaks right here at this point. A lot of times the truck apron will raise it up, and it'll actually come down in this direction a little bit and drain back to the inlets right here. In this case, we had a low spot in here, so we sloped the truck apron as well inwards through that. And having this slope this direction, that's giving us like a positive super elevation. So any car that's on this side, that's 14 feet wide, that's plenty of room for a car in most trucks. They get kind of a bonus of a positive super elevation rate of 2%. Whereas if we would normally design it, we would have had a straight line going outwards and have our inlets on the outside of the island. Here's our, here's our island in here. And then all the water goes to the outside. That's, in this case, if it's also a 2% slope, that would be like a negative 2% super elevation. So cars have to go a little slower on it, which is what we often want. We want them to go slower, right? So this one, you cross over that grade line and to the inside, and then you can go a little bit faster because you've got a positive super elevation. All right, through there. There's a good video here. It shows what truck aprons look like. You're going to be better off watching this at home on your...
This is a pretty big rig. 18 wheels, 70 plus.
We'll turn the volume up here.
Yes, we thought of that. Montana's roundabouts are designed for big rigs. They have what's called a truck apron.
There you go. Look at that truck apron.
At the center, the trucks and larger farm equipment are allowed to drive on going through a roundabout. Cars shouldn't drive on it, but it's designed for your rig's off-track.
There you go. And even that huge long trailer didn't off-track very much, right? They call that this is from Montana. We don't have those kinds of trucks here. It's called a Western double. And so that's a pretty common sight once you get out west.
And
So even with that huge long
A better way to get around.
trailer far back from it, it was able to handle it just fine. And how do I get out of this? There we go. We're watching, you know, YouTube always wants to just keep rolling with whatever video, so who knows what I was watching there. That's what our truck apron is for, and even like I say, we could see in that video, really large trucks can handle those, and that's what we designed it for. And this curb, yeah, it's rolled, or it's got a straight slope on the front. It's not that hard on the vehicles if you're going 20 or less, right? And typically a truck is going even less than 20 as it goes through the roundabout. But it's enough of a bump that most passenger car drivers don't want to go through it. And, well, we've got some examples coming up here that maybe some do. Here's an example of the design plans for what a roundabout looks like. And there's a lot of lines on here. This is the actual curb lines are right here. So this is the curb. Here's the curb over here, right? This is the center line of the approach. And here's our splitter island, right? I shouldn't say I'm getting good with this pen, but I'm getting better, except that always happens. Can't push too hard. Once you think you're going to want to do something else. So here's our curb line. Okay, and there, spoke too soon. Not very good. Here's the inside curb line. And here is the truck apron line. Whoa. Not very good. Through there, this was, this typical section came from this next drawing. So you can see this, here's our alignment line through the circulatory island. That's this line right here. That's what that line R is. From the last one. So that's our alignment, and it's also got a profile attached to it through there. And so this one is sloped inwards from here and sloped out from there. Just a little tidbit there. So what you may notice is, you know, if we did one alignment and one profile from one of our homeworks way before spring break there, right? So this has a ton of alignments in it, right? So here's an alignment line coming in. Right down here, here's one of the exits. Here's an exit. Here's an entrance. Here's the exit. Here's the entrance. Here's the exit. Here's the entrance. And then there's a circulatory roadway profile alignment. And then there's the master profile alignment line, which is running straight through this, right? And then these start here, and they've got an offset point on tangent off of that center alignment line. And they pick up, it's probably 2% straight over. They pick up the elevation off of that line, and then they run with it. And they go through here, and then they match into that. So this, a whole lot of alignments. They all have to match up perfectly where they meet, like right here, right? And so in each quadrant, you've got a spot where all those lines come together. And it could be for a little bit of distance, it runs as a single alignment, which is just that circulatory roadway, and then they pull off again, right, through there. So that's one example of how to design roundabouts. The reason you make this an alignment and also have a profile for it for elevation is to make sure it's super smooth. That's the whole point, is make sure there's a super smooth transition through here for vehicles as they come through. And this is so that's the overall look at it. And this was actually calling out where the splitter islands were in some elevations, right? This is actually what the alignments look like coming through there. And you can see here is our point of beginning, and it's also a point of curvature. So it starts out immediately in a curve. Here's the PI for it. Here's the end of that curve. Oh, it's a PCC. You remember what PCC stands for? Point of compound curvature. All right, and so we've got another curve, and then it attaches here, and that's the end of this alignment R1 through that. And then here we've got line R, which is a circulatory roadway, and then the exit one coming out of here, I think it's R2 or something like that, through there. It starts off, it's got a PI immediately in a curve. It goes to another PCC, point of compound curvature. Here's its PI, and then it ends down here. and it's when it ends, it's on alignment coming back out here, and we pick it back up using the center line alignment for this. This is the side road in this case, for its location and for its grade as it comes through. So these are really complicated, right? So we talked before about how to align roads. We rarely use compound curves. Well, in roundabouts, you use a lot of compound curves, right? This one actually starts on a tangent, and then we go into curve, compound curve, another curve, and then we tie in tangent then to the center roadway. Through that. So there's a lot of geometrics, a lot of stuff going on, but that makes a really smooth roundabout. Right? That's how you ensure that it's built really well. Now you could probably do offsets from the center line to all these points, but contractors aren't real good at, as complicated as this gets and as smooth as you need it to be, you're much better off in designing it this way with alignments through there. And here's an example. I don't know why it doesn't erase when you move forward, but I can erase that. All right, so here's an example. You moved in, here's that PCC, and then we've got another curve, and then it finally hits our point on tangent, and we hit tangent to this circulatory roadway alignment, which comes through here. Every one of these alignments has the bearings, it's got stations to it, it's got all that right through there. Oh, here's the end of the splitter line. Look, I used the 2-foot radius, which matched what the informational guide said. So we know each one of those alignments again has a profile, and so this is the profile for the circulatory roadway. That's this line out here. That's its profile. Through that, this line R1 is this entrance right here. Here's what this looks like. We come through, we get a little bit of a dip, we come in and we match. Well, whatever that station is, if we came up and matched where that was on line R, they'd better be exactly the same, and they'd better be at the same grade coming in as this roadway is. Otherwise, there's going to be a bump there and it's not going to be nice. So that's a lot of alignments, a lot of profiles. This lesson there. So here's our profile for that. There, some of them can be quite short, right? This is 200 some feet long, 207 feet long is all this one is through that. Actually, it starts at 100, so it's only 107 feet long. So that's a really short little piece of one. Through there, we can see also you have to maintain those grades and make sure that you got water flowing where it needs to go and all that. We saw this slide before, what that fastest path was. There's 3 cool videos over here that show people trying to do their fastest path. I'll try not to destroy it like I did last time. Here is car coming in. How's that, huh? So that's fastest path. Not a very... Let's back that up. This guy's in a real hurry. Yeah. So anyway, that's not the fastest path you want to do. We'll pause there. Then this next one here, let's see. This one's got stupid sounds. I'm going to shut the sound off. It's got kind of a yeehaw thing, but that's the best I could find. This guy goes up. He apparently fell asleep. He says he doesn't remember anything until he was airborne. So he shoots off right over it. Talk about fastest path, right? Right into a mud puddle, which is very well placed, if you ask me. And then he stops and gets out. He's fine through there. I think just scared through there. You should note the dog comes out to check. Dog checks on him. Yep. Then we fast forward a ways. This guy doesn't even care. Doesn't stop. Finally, someone stops, checks on him. You got smoke coming out of the car. But the important thing to note here is the dog comes back. There's a dog again. So the dog's very curious, just checking out the neighborhood there, I guess, through that. So let's pause this guy. And then we got one more fastest path. This is this one's a little bit nice one that shows a lot of different things about roundabouts. You're not supposed to cross the solid white line. This is showing how drivers, I think this is in Utah. And this is a very new roundabout. You can see I haven't even landscaped yet in the center. It's just opened up. But he does a nice job of showing how badly people are driving roundabouts don't know the rules about which lane to be in, not crossing the white lines, right? This is a sturdy road at LaPorte problem for sure. Everyone's always crossing those bypass lane line markings. See how they cross. So on your own time, if you want to watch this whole video, it's pretty cool. Just obviously, you know, we were thinking about what fastest path are, but people were just shooting all over the place. When you design fastest path, you actually normally don't take into account where the lane lines are because you assume people are going to ignore them. If they're going to do fastest path, they're going to ignore it. This is an odd roundabout where you got the single lane on this side, but then a dual lane on this side. So this is kind of a hybrid roundabout. Maybe that's what's confusing these people. Most likely it's just a new one in a new neighborhood, and people aren't quite sure what to do with it there. So you can watch those in better quality on your own if you follow the links. Again, this was what that fastest path, how we marked that out, and we saw that last time as well through there. Here, back to whether you're sloping in or sloping out, whether you've got the positive 2% like a super elevation or a negative super elevation. If you've got that sloped in, like a couple of the examples we looked at, you'd be the red line. So at whatever radius you were at, you're going to be a little bit faster. All right. So for 150 mile or 150 foot radius, you'd be at like 23 miles per hour, probably if you were sloped toward the center on it, whereas you'd only be, 21 or something. That's a couple miles per hour difference. It's a slight difference, but keep it in mind, right? If you slope toward the center, people go slightly faster. It's not critical, usually. It's usually not critical. It's either the higher the radius, the more likely, more difference it is. You see that spread coming through there. Okay, that's all for this time. Next time we'll finish up on roundabouts and we'll move into pavement.